So we are looking at the fear of people recursion, right? How well versed are you with recursion? Just a general question. Have everyone has some exposure to recursion at some point in their lives, or is there anyone who has no fucking idea what recursion is? Okay, I see a couple of folks having no idea at what recursion is. Akash also, Pratik, Ankur, basic. Okay. Mm-hmm. All right. Yeah. So I guess we will start assuming that you guys don't have any idea with respect to recursion, and then you can let me know if the level becomes a little too high sometimes. Then you can let me know. I will try to be as basic as possible to begin with, so that I give you an intuition. So today I want to start with, I'll just share the agenda for today, what we intend to cover today. So today we want to look at recursion, and obviously we will start with the basics. We will define recursion, and we will look at various types of recursion that exist in today's world. And after that, we will do maybe a couple of problems on recursion just to get our feet wet. Not very difficult questions, but yes, enough to give you a motivation as to how this works underneath the hood. And then after that, the real stuff will begin. So then I will probably give you a template, or you can say a framework for recursive formulations. So we will see how, given any question, how we can come up with a recursive formulation for that particular question. And then finally, we will apply it to solve questions. And some of these questions will be medium level, some of these questions will be hard. So yeah, your attention is definitely required. So this is the agenda. Sounds good with everyone? Guys,
Yes.
I want you to be more active. You can mute, unmute, tell me. I don't see a lot of
Yes, sir.
involvement from DSP1. I don't know why, but your batch, sometimes I feel that you guys are left out in some way or the other. So if that is the case, please let me know in whatever ways I can help you out. I will be happy to do so. So don't feel left out. Involved in the classroom. You are spending 2 to 3 hours of your every day in this particular class, right? So it is your right more than anything. It's your right to take something from the class, and so pay your attention. I understand it's a hectic day every day for you. You attend college classes, and then you come for this class after you've had a long day. But try to be as attentive as possible and interact with me as much as possible. Unmuting and speaking would obviously be appreciated more than writing yes or no on the chat. So please, at times, do that as well. And let's all just get pumped up and start Recursion. So all good? Shall we start? All good?
Yes, sir.
Okay. Let's start then. So what is recursion? Obviously, you start any topic, you start with a definition of recursion. So what is your perception of recursion? What comes to your head when you hear the word recursion? Can I have some answers?
When a function calls itself again and again.
Repetition.
Function calling itself.
So like a very basic scenario or a very basic case that keeps on repeating itself, I mean, and makes up a big solution or something like this.
Okay, so you're talking about problems and sub-problems, right? We will look at recursion from that angle also, but not immediately. Any other thing that comes to your mind when you hear the word recursion other than fear maybe?
Repetition,
Repetition in what sense?
like a same code is repeated.
Yeah, so code repetition is what we are talking about here. And Pranav is saying when he hears the word recursion, a recurrence relation comes to his mind. Okay, recursion uses stack, so stack comes to your mind maybe. Okay, anything else that comes to your mind?
Storing a value and using it at another time.
Storing a value and using it at another time, is that recursion really? That is not really recursion. What we are
Dynamic
talking about
program.
is DP. We will come to
Okay.
that. Yeah, Sayoni is telling a definition. It's like a loop, but better. Okay. Anything else? That's it? Yeah, dividing big problem into small problem. We will come to that that angle of recursion, but not immediately. We like in DSP2, I introduced it immediately because those guys were quite familiar with recursion, so I did not have to really go through the basics. But for you guys, let's do it maybe 1 hour from now. All right. So at a very fundamental level, recursion is nothing but the definition, the textbook definition of recursion is a function calling itself. So what that basically means is that if you have a function and you call the function internally in the definition of the function, then this is called recursion. This is basically at the very fundamental level what recursion means. So what does this mean basically? If you look at it, what happens? You have a function which you started invoking. Let's say in your main you are calling f. So what happened? When you called f, this started the controller came here and then you started executing these lines of code. Correct? So you executed some lines of code, these lines, and after that you call f again. So what does that mean? That means that the controller returns to f again. Correct? And then it again executes some lines of code and then calls it again, right? And then again it executes these lines of code and then calls it again. So what does basically this this calling something again and again, what comes to your mind when you hear this?
Infinite loop.
Looping, right? That's basically what looping was. Correct? So basically looping is you do the same set of tasks again and again. So you have in your loop prototype, you declare how many times you want it to run. At a very high level, you declare how many times you want it to run, and then you run the same body again and again. Correct? So this is similar. What you are doing is you want a certain set of lines to run again and again for some number of times. Correct? So it is similar to looping. Is this, first of all, is this thing clear to you? What exactly is happening when you are doing this sort of an action? You have a function inside which you are calling. I just told you 2 lines. I told you recursion is nothing but a function calling itself, and in basically when you call a function, you start executing those lines of code again. So and again and again. So basically you are just repeating a set of tasks over and over again. So it gives you, naturally it gives you an idea of looping. So now tell me, if this is what we mean by recursion, or this is what happens underneath the hood when we write a recursive function, then when will it terminate?
Base case executable.
In the loop, if you remember, there is a condition explicitly. Let's say in the for loop, here is the condition that you specify for loop termination. So every time you enter this loop, you check for this condition. And if this condition is met, then you return. you exit out of a loop, correct? Similarly, just take it as an analogy to understand recursion. You will have to basically terminate this. So when do you want to terminate? So basically in the function, what I'm saying is you should have maybe some lines here, some condition here, which you specify for the recursion to end, correct? So this is basically so what I'm coming at with this analogy with a loop is that every recursive function will basically comprise of two parts. In the first part, you will have a set of conditions when you want the recursion to terminate. And then in the next half, you will have the actual body that you want to execute again and again. And then you will call f again. Correct? This will, if I go ahead with this kind of a prototype for a recursive function, will this ensure that my function is finite and it terminates in finite amount of time? Correct? So let's take an example, just a very basic example to understand this for people like Karan who have no idea what is recursion. So let's say I want to print hello world. So guys, just keep following. 1 hour from now, you will realize how hard things are and things will start going above your head. So please follow as much as possible. So let's say I want to print hello world n times. So what is the iterative way of doing this? The iterative way of doing it is you say that I have a counter, which I will initialize. Generally, you guys use I as loop counters. So I will use I and I will run this for n times and I will just print out hello world. So what does this mean? This means that it will start with 1, it will print this, it will increment I to 2, check the condition, print again, check, increment, check, print, increment, check, print, and so on. So this is a loop that will run n times and it will print hello world n number of times. Now let's think about how we can go ahead and write a recursive formulation for the same. So how can we go ahead with this? I just told you at a very basic level, what I want is, I want this particular function to call itself again and again, correct? What is the task that I am doing here? The task that I am doing here is that I am printing hello world. So this will definitely be this part, the body, correct? So I can print hello world as many times as I want. So this will be the body. And here I want a set of conditions which I want the function to meet and terminate. So what can I do for that? I can have an iterator I in the function itself. And when I'm calling this function f, I can call it as f1. And I will have an n as well because I want it to go up to n times. So I can call it as f1 comma n. And what I will achieve out of this is that once I come here, I will be 1, n is let's say 10 for now. It will print hello world once. Now I want it to print 9 more times, correct? So can I call it like this? This basically is nothing but this phase. I have incremented my I by 1. And my set of conditions here to ensure that it terminates will be that if I has reached n, then I can terminate. Correct? So then I can return. So what does this return mean? This return means that you come out of this f. So now if you realize that when I becomes n, I don't call f again. I straight away return from here. Correct? Where do I return?
To the previous call.
To the main function.
To the main function immediately?
To the
No,
previous
sir,
call.
to the
To the
previous call.
previous call, right? To
Yes.
n minus 1. To when I was n minus 1, I printed hello world and I called it for n. So I will return here, correct? This is how function execution works, right? So if you see what happens whenever you call a function, let's say you are calling any function x here, what happens is the control goes to the implementation of that function. It executes these lines of code. Once it has to return, it returns here, right? Similarly, here what happens is once it encounters this return, it returns to the previous execution. And then from the previous execution, because the function has ended now, it will return to the second previous execution and so on. So let me make this more clear. So what I mean by this is you have an f, in, and you have some condition here, you have C out here. So the first time you call f from main, let's say you call it with 0, 10, it does not matter. First time you call f, what happens is in the memory, the control goes here. In the memory, you have a stack that is allocated for this instance of f. So generally what happens is when you have a main function, when you have any function, and if you're calling functions f1, f2, f3, so what happens is, let's say when you call f1, there is a memory that gets allocated for f1, which is in the stack of the primary memory, which is the random access memory. Then the control goes to f1, f1 is executed, and all of f1's execution, the memory that f1 uses, the local memory, is used from here, this particular stack. Once f1's execution is complete, it comes back here and this stack is deallocated. So now this stack is not there. Then again you encounter f2, another stack is pushed for f2. The control goes to f2, it executes some lines of code, uses this memory, comes back, and this memory is deallocated, and so on. Similar for f3, it will first allocate some memory for f3, go to main, go to f3's execution, execute f3, come back, deallocate this memory. So this is how function calling works in general in any programming language. So if you take that analogy, then here in recursion, what happens is you had a main function which was executing, right? So there must have been some memory for main, which was allocated. Now you call f. So what happens? The control goes to f. Memory is allocated for f0, 10. Now it starts executing the lines of code of f. So the condition, it first checks the condition. So it sees that I is not equals to n yet. So it does not execute this if. It comes here. It prints hello world to the console. And then it again calls f with I plus 1 comma n. So what happens when you call f with I plus 1 again? This is again a function call. So what will happen? The control will go to the beginning of the function call again. A memory will be allocated. This time it will be f1 comma 10. Then it will enter the function. It will again print hello world. It will again call with f2 comma 10. So now again a memory will be allocated for f2 comma 10. In this manner, it keeps accumulating till f9 comma 10. Now listen very carefully what happens. Now once you have allocated memory till f9 comma 10, it calls for f. So it calls for f10 comma n, correct? So when it calls for f10 comma n, the control goes here again. Memory is allocated for f10 comma 10. Now what happens is you see this condition is satisfied. So now what it does is you are just returning. So now you come back. So when you are returning to the caller, what happens is this stack is unallocated or deallocated. So this goes away now. So where does it return? It returns to f9 comma 10 because f9 comma 10 called f10 comma n. right? Now f 9 comma 10 9 comma 10 comes, the control returns to that. So now you are here. Now the function ends. There is nothing here. So this will also return. So where will it return? It will return to its caller. Who was its caller? f8 comma 10. So it will come to f8 comma 10. This memory will get deallocated. So f8 comma 10, it will come again at f8 comma 10. You see there is no line again after this. There is a end of function. So again that f8 comma 10 will return to f7 comma 10 and it will be deallocated. And in this way, it will keep returning. Finally, when you are at f0 comma 10, it will return to the main function, the person who called it. And this will also get deallocated. And in this process, how many times did this f run? It ran from 0 to 10. From 0 to 9, you actually printed hello world. And in the 10th time, you just returned. Correct? So hello world will get printed 10 times. Right? So first of all, is this picture, whatever I told you, clear to everyone? How a recursive function executes in the memory? Clear to everyone? Karan, is it clear? Some of you might already be knowing, but the people who don't know it, is it clear? Karan, do you get what it is? Do you get the analogy with iteration? Loops? Yeah, Karan. So return is nothing but, what is return? Return is just when you write return in any function. So you have a return. What does that mean? That means that you return from this function. Where will you return? You will return to the caller of this function. You will return to the function who called this function. So that's the return keyword in C++ or C. It returns to the caller of the function. Do you understand this? The print function will execute when, no. How does it, as in how internally it occurs in the memory? There is a stack pointer and a base pointer. So once the memory, once you return, basically the stack pointer is cleared out to the base pointer. Base pointer actually, so there are two pointers that keep track of any function, the base pointer and the stack pointer. The stack pointer points to the top of the stack, which is, and the base pointer points to the beginning of the stack. So when you return, this stack pointer is made equals to base pointer. And that is basically how this memory is freed. That's okay. We don't really need to bother ourselves with that. So the print function is executing Vidyut when, not while returning or allocating. It is a step-by-step process. When you call this function, memory is allocated first, then the execution happens, and then the return happens. So first the memory is allocated, after that the body of the function executes, and then the memory is deallocated when you are returning. So the print function is not getting printed while returning or allocating. It is getting printed when the body of the function is getting executed. It's a step-by-step process. Allocate, execute, deallocate, and return to the caller. That's it. That's basically what I've told you so far.
So in the 10th step, I is already 10, right? So when it goes to 9, it's again 10, so it returns 0. Then again goes to 8, it's return 0. So that's how it happens, right? Because I is already equal to 10.
No. So you're confusing that. See, you're confusing that. Here, you have an int I and an int n. And you are, see, this is the body. If I is n, let's say you are just returning. Here you are printing. Let's say you are printing stay indoors. Or let's say Corona sucks, you are printing something. And then you are calling f I plus 1, comma n. So tell me this, these variables I, n, let's say you write another int a. What are these variables? These variables are local to this function, right? Local to this particular instance of function. So what does that mean? That means that when this function is being executed, the value of I is basically what the value of I is in the body of the function. Nowhere else is this I visible. So when you had main, you called f0, 10. So in this stack, you had I as 0, n as 10. After that, so this got allocated, I got initialized to 0, n got initialized to 10. Then you printed stay indoors. And after that, you called f I plus 1, n. What was I here in this? I here was 0. So I plus 1 is 1. So 1, 10 now you are calling. So now stack is getting allocated for the next instance of f. So that in that next instance of f, there will be another copy of I and n because these are local to this particular function. So for this instance of f, I will be 1 and n will be 10. And you will again execute the body. So I1 is not equal to 10. So you will call stay indoors. And then again you will call I for I equals 2 and n equals 10. So on till you go I equals 10 and n equals 10. When I assign 10 and n assign 10, you will return. So you will return to this instance. I assign 9 and n assign 10. So if you print I here, let's say, after you have called this, let's say you are printing I. Let's say you are printing I. You will, after printing stay indoors, you will have called for I equals 10. You will return. And now you will print I. So what is I for this function? This function's I is still 9. This function's I is not 10. So there are 10 copies, 11 copies of I here. So here it will print I is 9. Then it will return to 8. Now 8 again, stay indoors has already been printed when before you called this. You have already printed this. So stay indoors was already there. And now you are printing I is 8 because I is not decrementing. It is just that
It's understood. Yeah. Yeah.
the function had its own local copy where I was 8. Correct. So don't mix I and n. I and n, every function has its own copy of I and n. It's not that there is one global I and n. There is one global I which keeps on incrementing and finally it becomes 10. So here also when you print, here you will print I, here I will become 0. If you print I here, here I will be 0 because you are passing it with 0. Here whatever variable was there for that I. Let's say it was x, int x equals 10 and you called fx, 10. So here I will be 0 if you are printing x. Correct?
Yes, I understood. Yeah.
No confusions in this?
No, sir.
When stack will allocate, then function, that's what I'm saying, Simran. Don't confuse it. It's a sequential process. You first allocate stack, you execute, how will you just think about any task that you try to do in your real life? How will you do it? First, you will prepare your resources that you need for that particular task. After that, you will execute that task. And after that, you will keep the resources that you had in their back to their original place. So similarly, here, when you are allocating the stack or the memory, you are just preparing resources. After that, the actual execution happens. So the execution always in C++ is sequential, unless there is an if else or something. So it is sequential in the sense after the stack has been allocated, it will start executing this line, then this line, then this line, then this line. And when it executes this line, it will print stay indoors. And then it will execute this line. So what will happen as part of that? As part of that, it will call f again. And what will happen again if it calls f again? It will allocate memory for the new instance of f again. And after everything will happen, let's say when you come back again, this line will execute. So now I will get printed. And after that, in this closing bracket or in this return statement, the deallocation will happen. Right, Simran, do you understand? So get these small basics clear. It will be very difficult to build on concepts. Shaurya has a question. In if condition, if we take I less than n plus 1, then the answer will be the same. Yes, because that's basic if else, right?
So when I equals to 10, then the
If I is less than n plus 1, no. If I is less than n plus 1, if you are taking, then it will return every time. It will return in the first call itself. Right?
I am audible.
Yeah, you are.
So when I equals to 10, the function is of value like int car. Then what value is returned to the I equals to 9 stack?
No value. We are not, every function does not need to have a return value, right? This function is a void function that we wrote. We are not returning anything. We just had an I and an n, and we were just doing something and then we were returning. We are not returning any value or passing any value to the caller, right? It is possible to have functions without
Yes,
any return
yes.
type. So we are not returning anything.
Yes.
Could you go back to the previous screen?
1 second.
Like, what is the f of I plus 1 comma n then in the middle right side?
This one?
Uh,
This is the call. This is the recursive call. I told you the recursion is a function calling itself. So in the body of that function, you will call the function again.
when it will be like, when it will be get stopped or executed here in
It
the,
will stop
in the
when
stack.
this, it will stop when this instance of f will be done.
Like f of 11 comma n 10, then it will stop. Right?
F of 10 comma 10, it will, there is nothing like stopping. Just think of it as function calls. It is just function calls. How do you call a function? That's basically what you need to be clear with if you want to understand this. How is f 10 comma 10? So when you are at I equals 9, you call it with f 10 comma 10, you encounter this if, where, and you see that this if has become true. You have still executed f10 comma 10. It's not that you have not executed f10 comma 10. It's just that in the body of the function, you have a function where you are returning. So returning is nothing but you are just saying that go here. Don't skip everything that is after this, just go here. So what happens when you go here? You will come back to the person, to the caller of this function. So who called it? F9 comma 10 called it. And after that, so this line has now completed its execution. Now the execution will come to this line. It's always sequential, one after the other.
Okay.
What can we do if we want to get our result value directly in our main function after calling n times? What is the question, Rahul? I don't understand the question completely. Can you unmute and ask?
So suppose if we do n times recursive function and we get our required value like in a result, suppose variable, and we want that value directly in our main function.
What result? Tell me the question.
Like there was a question today in hackathon.
We will come to that. Don't worry. But is whatever I'm telling you is clear to everyone?
Yes, sir.
Yeah, we will come to that. Don't worry about it. So do you understand? Does everyone understand how a recursive call is happening? Can I have a set of acknowledgements? Everyone, is it crystal clear to everyone?
Yes,
Don't
sir.
get confused. This is very confusing. I'm telling you, like you will start breaking your head. Just treat it as a function call. Always have your basics cleared. It is just a function call. So every time you call functions, that's the way it's happening. The way you would treat a function call, treat it in that way. Okay. Now let's level up a little bit. So now pay attention. So we told, okay, so far we said that what we want to do is recursion is nothing but similar to looping. You want to do some task again and again. We have a mechanism for doing that. And I told you this is how you do it. That's the story that I have told you so far. So now just a couple of terminologies to start with. This condition that you specified, the terminating condition, don't get bogged down by jargon. Just try to understand the intention behind those naming. Is called the base case of recursion or the base step of recursion. Why is it called the base step? What does base mean? Base means the smallest, right? So it is basically, it's called the base step of recursion. And this, everything else which is in the body is the recursive definition. Just some jargon, a little bit, a couple of terms that I told you. Now, let's see if this is clear to everyone. Let's level up a little bit. And okay, there are, should I introduce? Okay, let's do that first. Let's look at tail recursion. Okay, before that, let's do a question. I think that will make things clearer. Let's quickly do a question. This question is from the hackathon itself. So I guess many of you would have done it. Let me just pull it out. There's so many tabs open. Let's try this question. This was in the hackathon for people who did attend or take part in it. So has everyone read this question?
Yes, sir.
So just follow me, follow with me. It's fine if you don't have to try it on your own. I'll just share my screen. The screen is visible to everyone. You will have to read the question. You have to return the super digit of. So what is the question? The question is telling you, it has given you some conditions. The question is telling you that the question is basically telling you that you have a number. Let's say you have 6873. What you do is you first append this same number k times or p times, whatever is the metric. So let's say p or k is 3. So they're saying that you just append this and this is the number. So now what you do is you take the sum of the digits of the number. So 24 into 372. And then you again take the sum of the digits of the number. You continue this until you are left with a single digit number, and after you are left with a single digit number, the number that you are left with is basically the super digit that they have defined. So they are telling you return a super digit for a given number, right? This is the question that's given for. So let's see. What will be the first step? The first step will be to just sum up the digits of n k times. Okay. Shall we do that? Let's do that. I will have a long variable because otherwise the sum might overflow. So let's see. So how do you extract digits? That's basically nothing but how you extract. You will extract the units place first, then the tens place, and then the hundreds place, and so on. So what you do is at every step, you take the number modulo 10. So this is what I will do in the line number 13. The number modulo 10 will always give me a digit, correct? And I will add that digit here. After that, I will leave, I have to remove the units place and be left with everything that was there. So how can I do that? I can divide it by 10, right? So 6873, when I take a modulo with 10, I will get 3. I will sum that, then I will divide it by 10. So I will get 687. So now I will come back here again. I will take the modulo. So I will get 7. So I will sum whatever was the sum with 7 and so on, right? So this is how I will get the sum of the digits of n, correct? And I know that I have to do this for k times. So I can do this, right? So this is my initial sum of the digits. This part is clear to everyone? You don't have any issues with extracting the digits of a number, right?
The number is in strings.
The number is in strings, so that's okay. Let's do it in that way then. So then that's even easier. So number of characters of this string is num n dot size. I will go over each character of the string. What I will do is I will extract the digit. So what is the digit now? The digit is nothing but n of I minus 0, correct? And then I can sum the digits. Is this fine? Do you understand this? This is fine, right?
Yes, sir.
Anyone who does not understand this syntax? So basically, Drishan, what we are doing here is n of I is a character, correct? So every character internally has a number associated with it, which is called its ASCII value, ASCII. So there will be an ASCII value for 0, there will be an ASCII value for 1, ASCII value for 2, and so on. And these values are integers, but these are not 0 or 1 themselves. Okay. So if I want to obtain, let's say I have character 2, how will I get the exact 2 for that? Whatever is the ASCII value for 0, I will subtract from the ASCII value of 2, I will get 2. Right? So if the ASCII value of 0 was 68, it's not actually 68. It is, I don't remember the range, but let's say it was 68, 48. Okay. So if ASCII value of 0 is 48 and ASCII value of 2 will be 50, correct? So I will get 50 minus 48 here when I do a subtraction of characters and typecast it to integer. So I get a 2 here. Right? Everyone understands this typecasting?
So long it makes a problem.
Long ends, what? Come again?
Makes a problem. सर लॉन्ग एंड से प्रॉब्लम नहीं होगी क्योंकि सर क्वेश्चन में दिया हुआ है कि 10 की पावर 10,000 है मेरी एरे का साइज, और लॉन्ग इंट में इतने स्टोर नहीं हो पाएगा।
नहीं, 10 की पावर 10,000 एरे का साइज है।
हाँ, और अगर k की वैल्यू 10 की पावर 5 भी हो जाती है तब भी एरे बहुत बड़ी हो जाएगी, और एक केस में अगर मैं 9 लूँ किसी एरे में तो स्टोर नहीं हो पाएगा सम करूँगा तो लॉन्ग।
तो मैं लॉन्ग इंट में पूरा कैरेक्टर थोड़ी रख रहा हूँ, मैं तो सम कर रहा हूँ ना।
हाँ सर, वही सम नहीं हो पाएगा शायद।
अरे ये रेंज है n का, n का रेंज है ये, मतलब n कैन नॉट बी मोर देन दिस 10 to the power 10,000, 10 to the power 1 lakh. So 10 to the power 1 lakh is what? 1 followed by 6 zeros. n उस रेंज में है, n का साइज पे नहीं है ये कमेंट, दिस इज ऑन n itself. So कितना डिजिट है इसमें? 7 डिजिट्स है ना इसमें।
मुझे लगा इस साइज
नहीं, साइज नहीं है ये। दिस इज द रेंज फर्स्ट ऑफ ऑल नंबर का। सो वन फॉलोड बाय 1 लाख zeros, 1 लाख zeros, या सो 1 लाख zeros में मतलब हाउ मच? इट्स 1 लाख कैरेक्टर्स, राइट? सो 1 लाख कैरेक्टर्स, इफ यू सम द डिजिट्स, व्हाट इज इट? Maximum it will be 9 lakhs, right? 9 plus 9 plus 9, 1 lakh times. Let's say that is the upper bound. So it will be 9 lakh, correct? So 9 lakh is well within the range of an integer, let alone long integer. But when you multiply 9 lakh with k can be something like 10 to the power 5. So n into k can be more than 10 to the power 10. So that's why I have taken a long it. Right? Do you understand this? This is, I'm just summing the digits. So just think about how many digits are there in this number. Even if there is 1 lakh digits, it's fine. I can, what will be the maximum sum? 9, let's say 1 lakh times. That's basically 9 lakhs. And then you are just multiplying it with by k. So 9 lakh, let's say another 1 lakh times. So that's basically 9 into 10 to the power 10. Which is a little more than what an integer can handle. Integers can handle up to 10 to the power 9, you can say. Roughly 2 to the power 32. So 2 to the power 10 is roughly 10 to the power 3. All right. This part is fine with everyone, the constraints, or should I repeat what I?
Yes.
We are multiplying k times because it's given in the question. I'm not doing anything else. It's just saying that you have to concatenate this string again and again k times. So what will be the sum of digits of this particular entire number? It will be the sum of digits of this into k. So that's basically what we have done so far. Okay, so this is the first number that I got. Now let's actually get to the meat of the code. So I want to, let's see. Let's say I have a function super digit helper. It basically does what it is. So you get an idea, right? That this is a iteration. You are doing an iteration many number of times. Correct? First of all, let's do it iteratively. Now that you have a sum of digits, how will you do it in a loop? What will you do? You will say that while, let's say I have a temp here, what I will do is I will have a temp and I will say temp is some digits. So what I have to do is, let's come to this loop. I will run this loop as long as I have a single digit number. So till when I will have a single digit number? Once I start getting temp by 0 as 0, then I will be left with a single digit number. Correct? Here I will calculate the sum of digits of temp. I can do that again by the same. So digit is nothing but I modulo 10, and I can say that let me initialize some digits to 0. I can have some digits equal some digits plus digit, right? And after this I can have temp as some digits. This is how I would do it iteratively. Right? And once I am done with this, I can return temp. That will be the answer. Is this clear to everyone?
We can simply divide the number.
Hello,
sir.
Yeah, sorry.
Sir, we can directly divide the number with its we can do the modulus with 9. So that will in short give the super digit.
Modulo with 9.
Yes, sir. It will directly give the super digit. We don't have to do the while loop.
Okay. Yeah, that's fine. I understood. I'm just trying to give you a flavor of recursion with this. Okay.
Okay, sir.
Yeah.
Yes, sir.
So this is the iterative solution. Let's see. Why is this giving a wrong answer? Because these are, let's make all of these long now. It's okay. Okay. This part is clear to everyone. Do you understand how I wrote a iterative implementation of the same question, of the question? Can I have some acknowledgements if you understand? If you have any questions, can you ask? We will discuss that, sorry. We can take it up when we are discussing the questions of hackathon. Let's not take it up here. Okay. All right. So now suppose, now you realize that there is some task that is getting done again and again, and I want to have a recursive function for this. So how do I write a recursive function for this? So just think about what are the things that are changing. That's the first step that you should do when you are writing a recursive function. What are the things that are changing here? So at any point you have a number. So let's say I want to write a function. Let's say I want to write a function. Let's call this super digit helper. Okay. I know that there is a number which is changing, which is nothing but my sum temp, correct? So I will have a temp. What else? Nothing else. So this loop was on temp itself, correct? So let's implement this. So let's write the body first. I will formalize this in some time from now, but just try and get an intuition for this. So in the body of this, I know that in a particular iteration, what I am doing is I am just calculating the sum of the digits. This is the work that I am doing. And I am, whatever the new sum I have gotten, I am repeating with that sum. Correct? The while loop. So I will just do the same thing here. I will let's have long int sum of digits is 0. What I will do is I will start with temp. I will have a digit and I will have a sum of digits, which is this. Right now I want to iterate for this particular temp that I got, which is sum of digits. So won't I call super digit helper again with this sum of digits? Correct? So far so clear. I have just converted this iteration into a recursion. And in this recursion, if you see what in this loop, if you see what am I returning? I am returning a temp. Correct? So let me define this function as I will return the, okay, let's write the terminating condition first, the base case as I was talking about. So this is the body. What will be the base case? It will be similar to this condition in the loop, which is temp by 10 is greater than 0. So I will say that if temp by 10 has become 0, then you can return. Okay, this is the base case. I have just taken it from the loop itself. And now let's see. So these are the two things that I just, when I wrote a recursive function, I took two things into consideration. I just wrote the body of the function from the loop, and I wrote the base case from the terminating condition of the loop. And now finally I have to write a return type for this function. So what do I want to do here? I want to return this temp, right? This single digit that's there. Correct? So let's have a return type for this function, which is int. So what do I mean? When I have reached here, I know that I am a single digit number now. So I will return it to the caller. And here the caller will return it to its caller. Its caller will return it to its caller, and so on until the main function, wherein you say sum of digits, and I will return this temp. So is this clear to everyone? This will work. This is not working because of the formulation. I will be long int because you are using temp here. Okay. So is this clear to everyone? No, long is fine. Return type is not. It's basically the iterator. You are initializing I to temp, right? Temp can be long. What you return from the function will be a single digit. So you can have an integer for that. So clear to everyone so far? Shall we shift gears now? So now let's shift gears. So now let me tell you a couple of more things. So if you see, what did I do? I had a function. Let's just formalize what I did so far. I had a function with some arguments and some return type, and I was calling this function again with some other arguments. Correct? In the main function, you are calling f again with some initial arguments. So this initial arguments that you pass to this function is the actual problem that you want to solve. Okay. Every time you call this f, you call it with some different set of arguments. So these are nothing but sub problems. Do you get an idea why these are sub problems? Because when I call this function on a particular problem, when I call the function inside it, somehow I have to pass in a smaller version of this problem. And so then my idea is that I will pass a smaller version of this problem, which in turn will pass another smaller version and smaller version. In that way, the problem will keep reducing. And finally, I will get to the smallest problem possible. And for the smallest problem possible, I already know the answer. So I will simply return that answer. And then basically this smallest problem will go to the next smallest problem. What this will do is it will use the result of this smallest problem to formulate a solution for this problem, which will again go to its predecessor, which will again calculate the solution for this problem by using the solution for this smaller problem, and so on. And finally, it will return to main, and in the main, you will have the actual solution to the bigger problem. Right? Do you get this intuition? So this is basically what we will be using, or this is the perception that we will be having about recursion, is that we want to solve a problem. Okay. That's basically what we are saying. We want to solve a problem. So what I will do is I will solve sub problems. How will I solve sub problems? I will solve sub problems, and then I will combine these sub problems to solve the actual problem. This is how I will go about solving this problem. And that's basically what we will be employing recursion for. Is this view of recursion clear to people? Is there any questions on this? Do you get an intuition why the problem is becoming smaller and smaller as you, and it becomes the smallest here in the base case, and that's why it's called the base case. So, okay, if this is clear, then let's shift gears a little more and let's have a proper formulation for, yes, we are moving towards the base case. So another way of telling this is we are moving towards the smallest problem. So we are just reducing our problem again and again till it becomes tractable. And once I have a tractable problem at hand, I will solve it. And I need to have a way of solving the bigger problem from the smaller problem. So here, just to give you an example, here what we were doing was, we were saying that, or let's say take the example of printing hello world n times. What we were doing was, we were saying that, hey, what you can do is print hello world one time, which is your contribution. And after that, then what are you left with? You are left with a smaller version of the problem. What is the smaller version of the problem? It is basically printing this 9 times now. So you will keep going towards the smallest problem. What is the smallest problem? 0 times. 0 times, you know, the solution to this is don't print anything. And then you will come back and you will say that, okay, how will I print hello world one time? I will basically print my own version, and I have printed it 0 times. So I will print it one more time and I'm done. So then you will say, how will I print it 2 times? You will say that I will print it 1 time, and then I will print I will have my contribution, and so on. In this way, you will keep going up. Finally, when you are printing it 10 times, you will tell yourself that this is a big problem. I cannot solve this. I cannot print hello world 10 times. What I can do is, let my sub problem be that I want to print it 9 times. Somehow this will happen. I don't care how it happens. But once the 9 times is once 9 times it gets printed, what I will do is I will print one more time and I'm done. Correct? So this is basically what we are doing. Our actual bigger problem was printing it 10 times. We kept reducing it to 0 time or 1 time, you can say. Both are equivalent. Let's say you reduce it to 1 time, and then you know that for this I know the answer. For this my answer is just see out once, and then I will use that to solve the bigger problem and so on. So this is basically my view of recursion that we will be using throughout this set of lectures. Yes, so each iteration is basically using the result of the previous iteration in some way, which is the smaller problem, and combining it to abstract it. It is just combining it to solve the bigger problem. Okay, any more questions? Do you understand this view? Is there anyone who has no idea what this means? Do you get a feeling of the problem becoming smaller and smaller again, smaller till you reach a tractable problem, and then you come back? Everyone is getting this? Get an intuition of this. This is very important. We will build on this and like things will start flying. Okay, so if this is the view of recursion that we have, then let's talk about how to generally go about solving a particular problem through recursion. So now I will tell you how to go about solving a problem through recursion. So the first step will be, you should define a problem. So what does that mean? That means that you should define the parameters of the function or the variables that are changing in the problem. So how can you basically represent the problem mathematically? That basically means that how can you represent a problem mathematically? This is the first step to any recursive solution. So think about how can you represent a problem mathematically. So for the case that we were saying where we wanted to print hello world 10 times, I said that my problem mathematically is nothing but n. N basically represents my problem, which is basically the number of times I have to print hello world. Right? So this is the first step. Define the problem. The next step is define a decision that you can make at this problem. So mostly here, just to give you continue this example, the decision that we made here was that I have to print hello world n times. My problem can be represented by this variable n. So my decision is that I will print hello world once, and I will have a smaller version of the problem, which is n minus 1. This problem is what I will be left with. This is the decision that I made. After this decision, what you will have to do is, don't get bogged down by this jargon, but define, let's not write that, define relationship between the problem and the subproblem. So through decision, what I did was I was able to define a subproblem for myself. Right? So through this decision that I made here, which was basically the decision that I will print hello world once, I was able to define a subproblem for myself, which is basically nothing but n minus 1. Right? If I had made a decision to print hello world 2 times, then my subproblem would have been n minus 2. Correct? So now once I have a subproblem and a problem, I want to connect both of them, which is what I will do in the third step. which is basically I will define a relationship between the problem and the sub-problem. So here our relationship will be that let Fn denote, so in the let Fn denote that this function will print hello world n times. So I know that Fn is nothing but I will print hello world once union with f of n minus 1. Correct? And this is nothing but what is a recurrence relation. The relationship between problem and the sub-problem is a recurrence relation. There is nothing as such to scroll down. I can make it. Which part, Mrigank, you can't read? I can rewrite it if you want. No problem. Clear with everyone? Do you understand the abstraction that I am doing now? Is there anyone who is lost? Do you understand what recurrence relation means now? I just told you I want to go about solving a problem. That's what we computer scientists do. We just want to solve problem. So I told, let's define the problem first. Represent that problem mathematically. Otherwise, I will not have a way to code it. So once I represent it mathematically, let me define a decision for myself. This decision will tell me my sub-problem. And once I have a problem and a sub-problem, let me define a relationship between them. And then finally, in the fourth step, now write down the solution to the smallest problem. Which is nothing but, in jargon you want to say, it is define your base cases. And after that, implement. Okay, so this is basically the template that we will be using to solve problems. Tell me if it is clear with everyone. We will take up a question. Things will become even more clearer. All clear?
Sir, what is that f of n equal to hello world union f of
n minus 1.
Okay.
If I print hello world 2 times, if that is the decision that I make here, then it will be n minus 2. Now I don't need to be concerned with how this works, as long as this is solving the same problem for a smaller instance. I don't really need to be bothered about how this is working, as long as this recurrence is correct. That's basically one of the thumb rules of recursion, which will help you in formulating recursions with relatively ease. Okay, let's do a question, a very simple question. Let's say I tell you that you have an array. Just hear out this question. This question, you have an array of numbers. Let's say 3, 4, 5, 10, 12. And you have a sum. Let's give more. Let's say you have 7. Let's say you have 2. Yeah, that should be enough. And you have a sum, let's say 7. You have to print all subsets of A that sum to 7. So A is basically no duplicates. A has all unique elements, let's say. So this is the question now. So subsets are nothing but 0 or more elements picked from the actual set. So here, for instance, for this question, this particular example, the solution will be one subset is 3, 4, right? You can pick this and this. That should be 1. Another subset could be 5, 2. You pick this and this. These sum to 7. Another subset could be just 7. You just pick 7, the sum will be 7. Correct? So this is the answer for this. So you have to print me, give me a 2-dimensional vector, a 2D array where every 1D array is a subset. Okay? Is this question clear to everyone first of all?
Yes, sir.
Everyone? Yeah. So let's do this question with the help of the template that we defined for ourselves. Let's say it was 2, 5, 10, 12, 3, 4, 7. This was it. Now let's try to, and let's say your sum was 7. This was your array. So the first things first is you have to define the problem. So how can a problem be represented here? So for the problem, when you want to represent a problem mathematically, one of the tips that you can use is basically it's nothing but all the variables in the problem. So here, what are the variables? Your variable is the array and the sum. So let's say my problem is being represented by these two variables, a and sum. So how is it being represented? It basically tells me that I have a subset and I have to print all, I have a set or an array and I have to print all possible subsets from this array that sum to this sum. So this is how I can represent this problem. That's the first step I have done. The second step is the crucial step, that define a decision for the problem. And this is probably the most important step of any recursive formulation. If you are able to do this, then you will be able to solve the question. So one of the key things that you should use is this. These are just tips. Look at the eventual solution. To decide what you want to decide, to take a decision, look at the eventual solution. So here what I will do is I will look at the eventual solution. Let's look at the eventual solution for this. I say that this is the eventual solution. And now the decision one of the decisions that I can make is, let me look at the eventual solution and let me see 2. So I see that this particular solution can broadly be categorized into 2 sets. One set which has all subsets which contain 2. There is actually just one subset, and another set of subsets which does not contain 2. So from here, I made this decision that to solve this problem, I have 2 choices. I can either consider 2 in my actual answer, or I can, if I consider 2, I will get this, or I can choose to not consider 2, in which case I will get this. Correct? So this is the decision I made. This decision is clear to everyone? Do you understand how I arrived at it? Like, this will come with practice, how you arrive at decisions, but the general trick is to look at the eventual solution and see if you can divide that solution into categories. Like, I divided it into 2 categories, one set of subsets without 2 and one set of subsets with 2. So from here, I will tell myself, okay, so basically if I want to solve a sum, this is the problem that I want to solve. What I can do is I can choose to include 2, in which case I will be left with a1 to n or n minus 1 and sum minus a0. Correct? And if I choose to not include it, then I will be left with a1 to n minus 1 and sum. Right? So these are my sub problems now. if you see, these are nothing but smaller versions of this problem. How is this a smaller version? It's a problem with sum less than the original sum, even an array which is of less size than the actual array. So it's a sub problem. So now from here,
can you explain
Please explain
two
this.
conditions again?
These two conditions? Yeah. So you think about the decision. What was the decision? Can you tell me?
One has two and one doesn't have two.
One has two and one doesn't have two. So I tell myself that my actual problem was a sum. Okay. I have two possibilities. I can include two. I can choose to not include two. If I include two, then what am I left with? Or what is the problem that I have to solve this actual problem? I have to find a sum of 5, which is 7 minus 2 in this particular array. Right? If I'm able to find a sum of 5 in this particular array, then I can simply append 2 to it and I will get all subsets which have 2 in the beginning.
Yeah.
That's one part. The other part is basically all the subsets without 2. So then basically I am saying that then you have to generate all subsets with sum 7 from this part of the array.
Right, yeah.
That's basically what I represented mathematically. I told that I will be left with a 1 to n minus 1, this zero indexing. This is the array that I will be left with, and I have to find this sum now. Or I will be left with this entire sum and this array. Clear?
Yeah.
And
How do you get this arrive at the decision? Right?
With practice, but there will be like some standard decisions that we will go through in the 3-4 classes, and that will basically so most questions can be done with those decisions. For subsets, it generally include exclude, like that's one thumb. I will show you the same problem can be solved with another decision.
So like can't you like divide in the middle and take like 2, 5, 10 and 12, 3, 4, 7 and keep on doing it?
What will you do?
Like you take two subsets and 2, 5, 10 and then you take another subset that's 12, 3, 4, 7 and you keep on be dividing that into again more subsets.
That's okay, but what do you have to find in 2, 5, 10? What sum?
Like you again divide into 2, 5 and 10, then you take only 2, 5.
No, that I understand, but what will be the sum that you have to find for this subset? This is a smaller version of the problem, right?
Yeah.
So what sum do you want to find for this?
Basically 7.
Again 7. So you are saying that I will find all subsets for this and I will find all subsets for, what about the subsets which have some elements from this set and some from this? Like
okay. Okay.
You will not be able to generate them, right?
Okay.
Okay, so this decision is clear. Now, if I know this decision, I will talk about the recurrence, which is nothing but the relationship between the problem and the sub-problem. So now I tell myself that my actual problem is a comma sum. I know that.
So,
yeah.
Yeah, sorry to interrupt. What does eventual solution mean? Like, is that the final solution of the problem, or?
Yes, eventual solution is basically the final solution of the problem, which is basically the solution for the entire array and for the sum given, which is 7.
Okay.
So now I will define a recurrence for this. So this is nothing but this will come from the decision itself. So now I tell myself that there are two possibilities. One is if I don't include. So let me generate all subsets without without the 0th element, which is basically nothing but this problem. And apart from that, let me generate all subsets with this as the sub problem. The only thing is here I will push A0 in all these subsets. So every subset that I get by through a solution of this, I will append A0 to it. And that will give me all subsets which begin with A0. And this will give me all subsets that don't begin with A0. And then this is basically my answer for the entire problem. Right? Is this clear to everyone? The recurrence?
So could you please repeat that once?
Which one?
Sir, how you formulated it up, like how you combined everything.
So from the decision itself, I said I want to populate two types of okay, if you want to, let's see an example with this before we move ahead. Okay, things will become clear to you. We will do the fourth step, but let's see an example for this, and then I will take up some more questions. So let's take a simpler version of this problem. Let's say you have 2, 5, 3, 4. Let's say you just have these. Now, so this is the actual problem, and your actual problem was this array, comma 7. What you do is you have two cases. You can either choose to include 7 or choose to include 2, which is this element, or not include 2. If you include 2, what are you left with? You are left with 5, 3, 4 and the sum 5. If you don't include 4, what are you left with? You are left with 5, 3, 4 and the sum 7. Now for this case, again, you will do the same thing, right? Because so now if you do it again, basically what does that mean? That means you will either include 5 or not include 5. Let's say you include 5. So you will get a 3, 4 with a sum of 0. Correct?
Right, right, sir.
If you don't include it, you will get a 3, 4 with a sum of 5. Now here, this is one smallest sub problem. One such smallest sub problem, because I know that if my sum that I need is 0, then I have to return an empty set, because no subset is possible with sum 0 for any array. Correct? So from here, I will return an empty set to this, to the caller. And this caller, what will it do? If you see the recurrence, there was a union. So it will append 5 to the solution. So you will get a 5 here. Correct?
Yes, sir, right.
Is everyone following this?
Sir, why sum is 0 there?
Sum came down to 0 here. I kept on reducing my sum, right? From here, my sub problem was this, comma 5. From here, my sub problem was this, comma 0. Now I know that this is the problem that I can solve. What is the solution? An empty set. Right? So now so from here, basically I solved this problem. I returned an empty set. Now this caller is doing a union of this and this. And this is basically, if you see, it was A0 union F A1 to n minus 1, comma sum minus A0. Right? So this has returned now. And here I will append 5 to it. So after this, you can go down the branches, subsequent branches. Let me complete this example. Now, here you have Again, two cases. You can either choose to include 3 or not include 3. If you include 3, you will be left with 4 and a sum of 2. If you don't include 3, you will be left with 4 and a sum of 5. Correct? So from here, you will again either include or don't include. If you include 4, you will be left with a sum of, you will be left with an empty array and a sum of -2. If you don't include it, you will be left with a sum of, you will be left with an empty array and a sum of 2. Now these are again my base cases. These are smallest sub problems that I cannot solve, that I can solve. So for an empty array with any sum, I know the solution is an empty set. So I will return an empty set. Basically, the solution is nothing. There is no possible subset for this. Correct? So I will just return. I will not return anything. There is no solution possible. So this is not possible. From here also I know no solution is possible. So I will return NP. And now from here I will come back to here, and this is again NP, because unions of 2 NP will be again NP. Now I will go down this path. I can choose to include 4 or exclude 4. If I include 4, I will be left with an empty array and 1. If I don't include it, I will be left with an empty array and 5. Both the cases, nothing is possible. So NP, no subset is possible. So NP, this will again come to NP. Now it will take a union of both of them. It's NP again. Right? So do you understand how it is flowing?
Yes, sir.
So I will again come here. It's NP. Now here I will take a union of an NP and a 5, which is just 5. So I will return 5 to this. So now what 5 will do is it will append 2. So I will get 5, 2 from this part. So one subset that I will get from this is 5, 2. And similarly, I can recurse for this entire half. From here, I will be getting 3, 4.
So what is NP?
Finally here, one second, you will get 5, 2. When you union it, it will be 5, 2 and 3, 4. NP is not possible. There is no solution.
Okay.
Here there was a solution, which was an empty set, because sum 0 is always possible if you don't take any set, any element from the set. Right? Do you get some idea how this is working?
Yes, sir.
We will come back to the formulation again, but do you have some idea, everyone? So then let's come back to the problem again. So now that was the third point, the recurrence which I defined, which I said is f a comma sum is nothing but you take f a 1 to n minus 1 comma sum minus a0 union with f a 1 to n minus 1 sum. This is the recurrence. From here, I will define the base cases. So let's talk about the base cases. Now I will tell you some more tricks. There are two types of base cases for any question. You will have good base cases or positive cases, and you will have negative cases. So in general, if you want to write base cases, you should look at all the arguments in the function in this recurrence. So these are the arguments that are changing, or these are the arguments that have defined your problem. So what are the positive cases? The positive cases are that no matter whatever a I am left with, if I have a sum of 0, I can return an empty set. Right? This is the positive base case. This is the smallest problem from a sums perspective. What are the negative cases? The negative cases is no matter what set I am left with, If I have a sum which is negative, then obviously it is not possible. So this is a negative case. What else? Another case is if A becomes empty, completely empty. So I don't have anything in the array and I have a sum which is greater than 0, which I have to still find, then this is not possible. Right? Do you understand? These are the base cases. Does everyone understand these base cases?
So could you repeat that entity one? That A greater than 0 not possible.
So I'm just saying if you have at least one element remaining in the set and you have, if you have no element remaining in the array and you still have a finite, a positive sum left that you have to still compute, then it's not possible, right? You don't
Okay,
have.
fine.
So these are
repeat positive case.
Positive case is no matter whatever my A is, my A can have some more elements left. I don't care. If I have a sum of 0, then I know that my answer is empty set. Just think about base cases in isolation. Just look at this problem. You can solve this problem, right? If anyone tells you that, hey, I have an array with some numbers, can you find me a subset which sums to 0? What will you say? You will say, yeah, there is a subset which is the empty set. Similarly, for this, somebody asks you, hey, I have an array with positive numbers in it. Can you find me a sum that sums to -3? You will say no such subset is possible. Get lost from here. Similarly, in this case, somebody will ask you, hey, I have an empty array. I don't have any element. Can you find me a subset which sums to 7? You will say, obviously, there is no such subset. We will see the implementation and then we will think about that, where we return and where we don't return. Okay. Base case is clear to everyone? Just think about it. I will get my charger. I guess my battery has died. Just give me a moment. Hello, am I audible? Yeah, so far so good. Clear with everyone what we have done so far? Okay. So now let's think about what we have been doing so far. We are saying that my problem, if you see, my problem can be represented as f a. I just said that my sub problems were f a 1 to n minus 1 comma sum minus a0. Right? This was one such sub problem, and another sub problem was f a 1 to n minus 1 and sum. So what does this mean in English, in pictorial form? In pictorial form, it means that you find this sum in this part of the array. So how can you represent this part of the array? What is this? This is a suffix array. Correct? This is a suffix array of the original array. So how can you represent a suffix array of an array? Mathematically, you can say a comma I. This will give you a unique suffix array for a, right? Where I is the starting index. Right? Do you understand this? And how can you represent a sum? Through an integer variable. Anything. You can have x or you can have a sum. Correct? So my function that I will be writing will comprise of f a comma I comma sum. And what is my actual problem? F a 0, the target that I am given. Right? Does everyone understand how I defined the parameters of this function? So I just defined it from my sub problems, which is the fifth case. So now I'm talking about the case when I'm implementing. So when I'm implementing, I will have to represent my sub problem, right? So how can I represent a sub problem? I can represent a sub problem through, those will go as parameters of my function. So now I am telling myself what will be the parameters. It will basically be this suffix array, which can be represented with a comma I, and a sum, which can be represented by a variable.
So the I actually means the index from which we need to start considering our array, excluding the numbers that we have either tried to exclude or include, right?
No, I is, yeah, I is basically the start index of this array.
Okay.
Nothing exclude, include. It's the entire array you have to consider. Right? So let's write a let's implement this then. So I know, what do I have to return? I have to return a vector of vectors. This is a 2D array that I have to return. And my f, what will my f contain? My f will contain a vector, which is the array. You can pass it by reference, it does not matter. It will contain a start index, and it will contain a sum. This prototype is clear to everyone? Not what the prototype is, but how I arrived at it. Is this clear to everyone? You can ask me questions on this prototype. It's very important that you understand what this prototype, like how I arrived at this prototype.
Sir, please explain again.
Which one? Do you understand the parameters of this function?
Yeah.
These parameters represent a function, represent a problem. Right? I told that my problem is, what is my problem reducing to a suffix array and a sum. So how do I represent a suffix array? I told you can represent it by passing the original array itself, but along with a start index, which will basically denote the point from where your suffix array starts in the original array. right? Do you understand this, Rahul?
So, yes, so.
And then this return type is from the problem itself. The problem tells me to return a subset of all subsets. So a set of all subsets is nothing but the 2D vector, 2D array, wherein every row is one set. Correct? So I just did that. We will come to the base cases later. Let's talk about the recursive formulation. So what is the recursive formulation? Your recursive formulation is that let's obtain the result, which is nothing but the set of all sets that I get by excluding it. So when I exclude it, it will go to F. So I have to return, let's store it in temp, whatever this returns. This is F A start plus 1. So this is basically, I'm telling that at current start, I can include start or exclude start. If I exclude start, I will be left with A start plus 1, this entire array and the same sum. So let me get all the subsets of that. That's the first part. And the second part is, let's say this was temp 1. Second part is, let me include it. So include will be, let's store it in temp 2. I will say from start plus 1, I want to, but now my sum is sum minus A start. Correct?
Yes.
This is how I will do it. Now in this temp 2, I have to include A start. So how do I do it? I can go over in a loop. Let me go over in a loop from 0 to temp2 dot size. What do I have to do? I can simply push this element in temp2. Correct? So this now after this, do you understand that my result will be temp1 union temp2, and I can return this result. You can take a union by creating a 2D vector and iterating.
So why do you loop through? Can't we just push back the starting element to temp2?
No, this is a set of sets, right? This is a vector of vectors that you get.
Yeah.
So you will have a lot of subsets where you have to push 2. How do you do that? So your original set was, if this was your original answer, you divided it into 2 sets of sets. In these sets of sets, you don't have 2. You have something else.
Okay.
And in these, you have to push 2 to get a total sum of 7. You have only gotten sum of 5 so far. So you push 2, you will get a sum of 7. So I have iterated, looped over all these elements and pushed 2.
Okay.
And then I am finally taking a union of these 2 to get an answer for this.
Yeah.
And I can return this. Correct? So this is basically the recursive formulation. Now let's write the base cases. So the base cases, generally you should always write the positive cases first and the negative cases later. So what was the positive case? The positive case was that if your sum becomes 0. So if your sum becomes 0, you can return a empty 2D array. This is an empty 2D array, 4 braces. So this is basically a 2D array with one vector which is empty. So this is, you have 2D arrays, right, with multiple rows. Here I just have one big 2D array with just one row, and that row is an empty vector. Correct? And what are the negative cases? You can write for yourself. One such negative case is that if your sum becomes negative, that's one case. What are the other cases? Or a dot or start becomes equals to a dot size. Correct? When start becomes equals to a dot size, if you come here, you cannot have a sum of 0 now, right? Sum will either be positive or negative. If sum is negative, I don't care about the start. If sum is positive, then if the start has become equals to the a dot size, I have to return something. So I can return an empty vector. So basically what I can do is I can return this. This will also work. This is nothing but an empty 2D vector, signifying that it is not possible. And that is the complete implementation.
Sir, could you please explain the difference between the first return statement and second return statement?
This is not an empty 2D vector. Here you have a 2D array which has just one element, which is an array of size 0. This is a 2D array which does not have any elements.
Okay, sir.
Right? Is this making sense to everyone?
Sir, for the case where sum is 0 and also we have exhausted all the elements, in that case we will enter the first if condition also as well as the second.
I will not enter the second if, right? I will return.
Oh, okay. Yeah, sorry.
Let's take more questions. So Sakshi, you understand this now? Like what negative cases mean? I guess your question is answered. What else?
Sir, are the exclude and include, does it tell like to exclude or include first element?
Yeah, basically the element with start.
Okay.
At index start. Devanshi, is it possible that we have 3 elements in a subset? Yeah, we can have as many elements as we want. Sorry, I don't get your question. Why do you need to take the minimum? Here, AI must be less than the remaining sum, which will be handled in this base case. I guess this question is also answered. Can we divide this problem if we take 3 instead of 2? You can divide it, Devanshi. That should also be fine. It's just that your subproblem will not be a suffix array anymore, right? So what Devanshi is telling me is, let's answer that question. That's a good question actually. So we have an actual array, right? You have 2, 3, 4, 5, let's say, and you want to sum 7. So Devanshi is saying that you took a choice on 2. Why didn't you take a choice on 3? You can divide it on 3 also, right? So yes, you are right. If you can divide it on 3 as well, You can choose to include 3 or not include 3. But tell me this, if you include 3, what is the sub problem that you will be left with? You will be left with 2, 4, 5. Correct? And a sum of 4. If you don't include it, then also you will be left with 2, 4, 5 and a sum of 4. How do you represent this 2, 4, 5 with respect to the original array? This is not a suffix array. This is nothing but a subsequence of the actual array. So to represent this problem, you cannot represent it by just a and I. Correct? You will have to represent it by an array and a visited vector, wherein you would have marked visited of this particular cell, whatever that is, to be true. And of course the sum. So this will be your sub problem then.
So, is there any restriction that any element, any one element can be included in only one subset of the solution?
No, there is no restriction as such. Every element needs to be included only once in the subset. So you cannot have a subset of this type 2, 2, 3. This cannot. This is not possible. But 2 can go into as many subsets as you want. 2 can go here, 2 can go here. That's fine. Right? Ask me questions if you guys have any, or acknowledge if you understand everything that we have done so far. Like more, not so much the formulation, but more as to how I arrived at that formulation. So there were a lot of key things that I told you. I told you how to represent a problem. I told you how to represent a sub problem. I told you how to write recurrence, how to write base cases. And there is one more thing which we will come to. Explain the for loop. Karan, so in the for loop, what is, tell me this, what is the, when you call the function f on this part of the array, when you call f on this part of the array, what will it return with sum 5? What will it return? It will return you all the subsets which has sum 5. So it will return you 5. That's one subset. Let's say there were more elements. Let's give it, and it will return, let's give it more elements just to make you understand. Let's say there was a 1 also here. So it will return you 5 and it will return you 4, 1. Correct? If you do it on this particular entire array, excluding this 2 with a sum of 5. So what you have to do is you want a sum of 7 for this entire array. So how do you find a sum of 7 for this entire array? You append 2 to all these subsets. So you go over each of them and you push back 2. So now you have gotten a sum of 7 for the entire array. That's one part. The other part is if you have already gotten a sum of 7 from this entire array, excluding this. So if that is the case, then you don't need to do anything. And you take a union of both of them. That's basically your answer to the actual question. So 2D array having an empty set is a 2D array. So basically, if you have a vector of vectors T, let's say of size, let's say T, and you set it to this, then T dot size is 1. If you go over this loop, you will get this, and you can push 5 to it, or you can push 7 to it. But if you return an empty 2D vector, then its size is 0. So if you go over the loop, you will not be doing anything. If you take a union, you will not be adding anything. And did I answer your question, Sakshi?
Hello, sir. Am I audible?
Yeah, you are.
Sir, actually, I know the difference, but why do we have to differentiate between those two arrays in the base case? Like, can't we return either an empty 2D array in both the cases?
No, because those are negative base cases. So for them, the solution is not possible, right? So what do you mean when you say your solution is not possible mathematically? It means that your entire 2D array has to be empty that you are returning.
Okay.
And in the first case, when sum was 0,
Huh?
there was a solution. What was the solution? The solution was an empty subset. So your 2D array will contain that empty subset.
Okay. Okay, I got it.
Yeah, we can discuss that after the class, Mantevya, okay?
Sir, how will you actually take the union of these two conditions?
You can take another vector of vectors. It's not very efficient, but doable. Take a vector of vector, which is a result. Go over, you can do a rest dot pushback temp 1, and then again do a rest dot pushback temp 2. So when you are pushing here to res is a 2D array. So when you push, you have to push arrays. You have to push 1D arrays, right? So you can loop over all the elements of the temp 1 and keep pushing them. And then you can loop over all elements of temp 2 and push them to result. Right? Because temp 1 is also a 2D array. So you can, so temp 1 is of this type. Temp 2 is also of this type. So you want to construct a result, what you do is you go over each of them, push them, and push this, then push this, then go over these are temp 2, push this, and push this. Correct?
Yes, sir. And sir, there is one more doubt. Like, sir, there are in the negative base case, there are two conditions. When the 2D vector is empty and sum is less than 0, and another one is when the vector is empty and sum is greater than 0. So I think we have to write both the base cases.
We wrote both the base cases in the OR, right? We wrote this. We wrote that if, what did we write? We write if sum is negative or start is equals to a dot size. This has both the cases, right? This is the sum empty wala part. So if sum is negative, no matter whatever your a is, you will have to return. This is negative, case 1. What is the second case? Second case is if you have an empty array and you have a positive sum. So by the time you come here, you are left with only one case where sum is positive, right? Because before this you had taken care of sum 0, and here you have taken care of sum negative. So if you are here, that means that your sum is positive. So I did not write that explicitly here, and sum greater than 0.
Okay, sir.
You can write that also if you want. Any more questions? So you should be able to represent the problem on your own, which is basically A, I, and sum. This came from the decision. Another important thing in recursion is the mission statement. So basically, a mission statement is nothing but tells the function what it does. So f a I sum, the mission statement for this is that it returns all subsets with some equals to sum for array I to n minus 1. This is the mission statement of this function. So whenever you write the recurrence relation, make sure that you are adhering to the mission statement. So here I told you, if this is what f means, then I can say that this is nothing but union of f a1 comma sum minus a0 union, this is a small union, and f a comma 1 comma sum. So f a comma 1 comma sum tells you that return all subsets with sum as sum for array 1 to n minus 1, and this tells you return all subsets with sum minus a0 from array 1 to a0. So it's very important to be consistent with the mission statement. Don't violate the mission statement. If you are able to spell it out in English, you should be able to write a recurrence relation also for this. That's also one of the key things that we should keep in mind when you're formulating a recurrence.
Sir, could you please return this, repeat this mission statement?
I will repeat. Vidyut has a question. Empty 2D array and 2D array with empty set. What do you not understand, Vidyut, in this? You have an array which is a 2D array. You can have an empty array in this, right? Or the other case is that you can have a 2D array without anything in it. So this still has one element in this 2D array. So this, if this is R, then R dot size is 1 here. Here R dot size is 0. So when you loop over this, you will not be looping anything because this is empty. Here when you loop over it, you will loop over this. And here you can push 5 or push 2 if needed. It will count. That's why it's important to return this to empty vector. It will not count independently, but you will have elements appended to it in the for loop. Just do a dry run in your head. You will understand. So mission statement is nothing but what the function does. So you have a recurrence relation that you arrived at, right? Through the steps that I told you, 1, 2, 3. Now, when you are defining a recurrence relation, you should always keep in mind the mission statement also. So mission statement is nothing but what the function is doing. So the function is doing what the question is telling you. What is the function doing? It returning all the subsets with this particular sum for this particular subarray. This array is nothing but I to n minus 1. This was I. Right, Akash? Do you understand this?
Yes, sir. Sir, so basically mission statement is something that we get in the decision making part.
Yeah, it is in the decision making and as well as in the recurrence. You will have to use that mission statement in both. In decision making, you will get a sub problem, and then when you are defining the recurrence, it's important that you define a mission statement and adhere to it.
Okay, sir.
Right? All clear to everyone? Should I repeat anything? Do you want some more time to grasp this? Shall I move ahead? What is the consensus? Shaurya, is it clear? Shravan, I guess it should be clear to you. Shubham, is it clear? Saurav, it should be clear, I guess. Susrit, is it clear? Tanya, clear? Tulika, Utkarsh, Jadav, Drishan, Ayanva, Ankit, Akshay, Akash, Mansi, Kush, Hemant, Hardik, Dominic, Divya. All clear to everyone? No issues with this? Okay, if no issues with this, let's do another version of this question, which we will actually code in the editor. Same question, you are given an array of numbers, no duplicates, and you are given a sum. You have to find all subsets that sum to this particular sum The only constraint is that an element can be taken as many times as possible in the subset. So previously, if you see, we had this constraint that in a given subset, this particular every element will be included only once, at least exactly once, or at least at most once. Now the question is that you can include an element any number of times. So let's say your sum was 6, then 2, 2, 2 is also answer. 3, 3 is also an answer. 2, 4 is obviously an answer. That's it. These are the answers basically. This is the question. I will give you the link to this question. But do you understand the question, everyone? So now let's do the same exercise recursively. I'll just paste the question here. This is the question. Samarth, are you understanding? Sai, are you understanding? Saina, Rashmi, Radhika?
So,
yeah.
If there is a zero, go in an infinite loop, right?
Come again?
If there is a zero in the array, it will go in an infinite loop, right?
Yeah, it's all positive.
Okay.
It's all positive numbers. So let's go over it step by step. First things first, let's represent the problem. How do you represent this problem? The problem is again an array and a sum. So it's fine. No brainer in that.
So earlier you mentioned here we could use each element from the array multiple times.
Yes.
It says each number in candidate can only be used once.
Did I paste that? Oh, try this then. Just my bad. Yeah, I pasted the wrong link. It's my bad. This is the question. So what is the decision here?
So can we take subsets with multiple elements of first element and those without only single element of first element?
So we can make 3 decisions over here. If we want to take an element and change its sum, if we don't want to take an element and not change the sum, or if we don't want to take an element, like basically go to the next and not change the sum.
Take an element and not change the sum. How is that possible?
I mean, so take an element and change the sum. Like, do not go to the next element, as in don't reduce the size of the array.
Yes. So how do you formulate that? Like,
so the size of the array would be same, but the sum would reduce by some. Like the sum would be sum minus a naught.
Yeah, I got you. That can actually be like clubbed with one of the decisions that you made, which is basically take an element. So here, if you see, again, for this decision, let's go through the same exercise. Let's look at the eventual solution. It will be of two types. Solutions where the first number of this array A0, let's say it was 2. So solutions where 2 does not occur at all, correct? Other numbers occur. And then the solutions where 2 occurs at least one time. Correct? So can I take a decision here that I can choose to exclude 2 completely or include it at least once? So what that will boil down to is, if I exclude it, then I will be left with a1 to n minus 1 and a sum of sum, whatever sum I am left with, I have. If I include it at least once, I will be left with the original array completely and sum of sum minus a0. Is this decision clear to anyone?
Yes, sir.
Right? So then let's talk about the recurrence along with the mission statement. So now let's see, what is the problem reducing down to this? So this is what? This is a suffix array. So how do I represent a suffix array? I can represent it with a and I. And this is a sum. So these will be the variables or the arguments to my function. Correct? And what will be the mission statement? That this basically returns all subsets as given in the question, like with the constraints of the question, that each element can be included as many times as possible. All subsets of a I to n minus 1 with sum as sum. This is the mission statement. So I arrived at this thing in 2 steps. I first decided the arguments for this, and these arguments I decided on the basis of this decision that I made. From the decision that the sub problem that I am left with, I told myself that this sub problem can be represented in this manner. This is a suffix array, so I can represent it with an array and an I, which is the starting index, and this is a sum which I can represent through an integer variable. So from there I concluded that the arguments to my function are these 3 variables. And then I said the mission statement is then nothing but the actual problem itself defined to this subproblem. So what is the actual problem? Problem is to return all subsets of a I to n minus 1. So I have just defined the actual problem again with respect to this subproblem. And now if you know, this is nothing but, if you know the decision, then it's fairly straightforward. It is basically union of, if you don't include it, then it is fa1 to sum. If you include it, then it's basically a0 union fa0 sum minus a0. Right? And what are the base cases for this? The same base cases will work here also.
So when we're including y, we again doing union with a0 because we're already including it in the f only, right?
We are including it. So what is this subproblem returning? Read the mission statement for this subproblem. And read the mission statement for this problem. Right?
No, sir, I didn't understand.
So this subproblem, what is it computing? It is computing all subsets of a0 to n minus 1 with sum as 5 now, not 7. So once you get all subsets with sum as 5, you will push 2 to push back 2 to all of them to get all subsets of sum 7, which is the solution to this problem. You want a subset, all subsets of sum 7. Correct?
Yeah.
So that's what I'm doing. This is I plus 1 and this will be I.
So how does this ensure that like multiple you can have duplicates? How does this ensure that we have duplicates?
Because this problem again will, when you solving this problem, you will again consider A0 again.
Okay.
Right? Because your index you haven't incremented. Do you want to see an example, a recursion tree for this?
Yeah.
Others?
Yes, sir. Yes, sir.
Let's see a recursion tree for this. So let's say you have 2, 3, let's take a simpler one, 4 and 7. You want to make a sum of 6. This will still be a big tree, but it's okay. Let's do some steps. So 2 cases, you can either include it or not include it. So if you include it, you are left with this entire array again. Now this is the difference. So you are left with this entire array again and a sum of 4. If you don't include it, you are left with 3, 4, 7 and a sum of 6. Let's come down to this path. You can include it, not include it. If you include it, you are left with again the entire array 2, 3, 4, 7 and a sum of 2. If you don't include it, you are left with 3, 4, 7 and a sum of 4. Come down again. You can include it or exclude it. Let's include it. You will be left with this entire array 2, 3, 4, 7 with a sum of 0. If you don't include it, you will be left with 3, 4, 7 with a sum of 2. Now this is the base case and it's a positive base case. So you will return an empty set, an empty 2D array. From here you will go here. So once you come here, what you will do is you will iterate over each of these elements and push 2 to it. So now you will have a 2D array with 2 as one of the elements. Then here you can similarly proceed, right? There won't be any solution. So let's not go here. If you want to really do it, let's do it for one more case, maybe one negative case, or we will do it here then. Let's see. So here basically you return from this entire sub branch, you will return an empty 2D array. So here what you will do, you will iterate over this. There is nothing. So you will not, in any case, you were not pushing anything. So this union, this will be returned to this. This will be basically this. This will be returned here. Now what it will do is it will iterate over all these elements and push 2 to it. So basically this becomes 2, 2. And here you can go ahead with this. Again, you come here just for this. If you are coming, it will push again 2 here. So you will get a 2, 2, 2. Right? This is one possibility, this, and this is how it will come. If you want, you can go down here further. Right? Is it clear? Or should I go down further? 2 more cases.
Yes.
Clear? Is it clear how you are getting duplicates?
Yes, sir.
Yeah.
And of course, cross, if you want 2 and 4, you want to see how 2 and 4 is getting added, then you should come down to this path, this path. So here you have 3 included, not included. If you don't include it, you are left with 4 and 7 and a sum of 4. So now you will have 4 included or not included. Let's include it. You will be left with 4, 7 and a sum of 0. So this is a base case. Positive base case, you will return a 2D empty. Here you will push 4 to it. So you will have this From here you will push, you will not append anything because this was a cross. Come here, you will not append anything because this was a cross. Come here, you will append 2 to it. So you will get a 4, 2. And here you will take a union of both of them. So you will get 4, 2 and 2, 2, 2. Correct? So let's code it quickly. I see people dropping off. Or you can code it on your own. You can code it on your own. You can give it a try, right? Or should I do it? What do you want? Yeah, I mean, try it on your own. This will be a good exercise for you. I have given you the pseudocode for the actual problem, right? I mean, the previous problem. So I think this should be tractable. All right. Do you want to do more? Or are you guys like, is it, let me know when it becomes an overload. You want to do a puzzle? Does everyone wants to do a puzzle? Quickly. It's a democracy. I need votes. Otherwise, how will I understand? What do you want to do? It's pretty even. Let's okay, let's, you want to coin flip? You want to do a, okay, let's do a very simple puzzle. I guess we are even, pretty much even. We can take a veto from someone. Who is there? Let's do a very simple puzzle. It's a it's a good puzzle, interesting puzzle. So maybe take, if you don't want a puzzle and you feel that your voice is not getting heard, please put in votes. Otherwise, I will not have any way of knowing. Akash has written no puzzle 5 times to increase the vote count, similar to what BJP does. Okay, so let's see. This is a very simple puzzle. Just hear out very carefully. You are given a deck of 52 cards, okay, out of which 13 cards are placed facing upwards. So you understand what you mean by facing upwards and facing downwards, right? Facing upwards is basically you, the card is not, you are able to see the number and the suit of the card, and then, or the suit of the card. And then you have 39 cards which are facing downwards. Okay. So you have a pile of 52 cards, out of which 39 are placed upside down. So they are hidden. The contents are hidden, and 13 of them are faced upwards. So on those 13 of them, you are able to see what's written. Like, let's say it's an ace of hearts. So 13 cards of this type and 39 cards of this type, you are there. You have a pile of 52. What you have done is you have randomly shuffled these cards. So now you don't know the position of these 13 cards. Now I blindfold you. You did not see this. I blindfolded you. You are sad because I blindfolded you. Now I blindfolded you and I gave you this 52 cards. What you are doing now is you have to, I give you this task that, hey, divide it into 2 piles, pile 1 and pile 2. these can be of unequal sizes. It can be that this is 36 and this is 16. It does not matter. Divide it into two piles such that the number of cards facing upwards is same in both the piles. What you can do is you can randomly flip a card, but you are blindfolded. So when you are flipping a card, you don't know whether that card was upside down or facing upwards in the first place. You can just randomly flip cards. You have to tell me a strategy such that if and when you flip some cards and then you divide it into two piles, the number of cards facing upwards will be the same in both the piles. The only operation allowed is flipping. Don't tell me that you can touch and feel and get to know that this is a card which is facing upward. Okay, do you get it? Do you get the question? Do you get the question? Others?
Yes.
Sir, what do you mean by flipping?
Flipping is basically if the card was faced upwards, then you will, when you flip it, it will face downwards, and vice versa.
So the number of cards which are facing upside is the same in both the stacks.
Yeah, you have to flip in such a way and divide it.
Sir, is it audible?
Yeah. Yes, sir.
Sir, we can take any 13 cards and just flip them up.
That becomes your first pile.
Yeah.
Yeah.
So basically what will happen is consider the 13 which I have pegged at the one pile and the rest 39 are the other pile.
Mm-hmm.
So let's consider say out of those 13, say A and are facing upwards.
Mm-hmm.
So which means that you initially said that 13 cards were placed upwards. So that means in the second pile, 13 minus n cards are flipped upwards.
Right.
So when I flip those 13 cards, then then reverse it will happen. When I brought the first 13 piles, then it was n. After I flip all of them up, it will become 13 minus n, which will be equal to that in the right side.
Right. That's correct.
Yeah.
Did anyone understand what he told? So what he told is take the first 13 cards in the pile and flip all of them. So if in those 13 cards you had X cards which were facing upwards, now you have 13 minus X cards facing upwards. The remaining 39 has 13 minus X cards facing upwards because the total number of cards that were facing upwards were 13. सही है? सबको समझ आ गया? Let's move on. If you understand this, let's do this question with another decision. So try this question. Now I want to give you an idea of another decision so that you can just give it some thought. The same question. So I tell you that, sir, you had these numbers 2, 3, 4, 5, whatever, I don't care. And I have a sum. What the decision that I made was to include this or exclude this. Let me see the solution. So for making a decision, I will always look at the final solution. So let me see the solution now again. It has different subsets, right? I tell myself that can I divide it into n subsets n sets of subsets such that two is the minimum element in all these subsets. 3 is the minimum element in all these subsets. 4 is the minimum element in all these subsets. Minimum. Mark my words, minimum. Not the 5 is the minimum element in all these subsets. And 6 is the minimum element in all these subsets. Obviously, such a division is possible, right? So can I make a decision thinking this? Anyone? Do you get this first, what I told? This division of the solution? No. Yeah, 2 can repeat, it's fine. But it is the minimum element in all these subsets. So in this subset, you will not have a 3, 2. You can have a 4 here. You can have a 4 here because 3 is the minimum. You can have a 5 here. You can have a 6 here. But the minimum element in all these subsets is 2. The minimum element in all these subsets is 3. Minimum element in all these subsets is 4.
Sir, could you repeat that?
All the subsets you have of the answer. Let's take a sum of 6. Let's take 6. I like 6 for some reason. I don't know. So what are the solutions? You can have 2, 2, 2. You can have 3, 3. You can have 2, 4. You can have 6. Correct? These are the subsets. So look at all these subsets. This subset, you will have some minimum number. 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 So now I tell that I can divide all these subsets into n categories, where n is the size of the array, such that the ith subset basically contains ai as the minimum. So this will go into the bucket for 2. This will go into the bucket for 2. This one. This will go there. This will go in the bucket for 3. This will go in the bucket for 6. These will be empty. There won't be any subsets. So if I sort the actual array, the original array, can I have a decision around this? Do you get this first of all? The not the bifurcation, the n-furcation, or the division of this.
Yes, sir, I got.
So can you tell me a decision, or what if I make this decision? What are the sub problems that I'll be left with? It will be a union of these 5 functions, but what is the sub problem that I'm left with? So this 3 can have 4, mind you, but it cannot have 2. Similarly, this 4 can have 5, but it cannot have 3 or 2. It will be a union of this. That's true. So for this, if I include 2, my sub problem can you think?
So that I that you start from, for the first one, it'll be 0. For the second one, it'll be 2. I mean 1. And then for the next one, it'll be 2.
Yes. So for this, my sub problem reduces to a0 to n minus 1 with some minus 2. For this, my subproblem reduces to a 1 to n minus 1 and sum minus 3. Because I have sorted the array. 1 to n minus 1 includes 3. So I can have repetitions. Is this clear? For this, it will be sum a2 to n minus 1 with sum minus 4. A3 to n minus 1 with sum minus 5. A4 to n minus 1 with sum minus 6. In the previous problem, wherein we had only exactly one, we could only pick an element exactly once, how would this, if we take this same decision, what will our subproblem be? Do you understand? In the previous question, not this question. This question, you can have a number as many times, right? If you are allowed to choose a number exactly once or at most once, what will your subproblem then be if you make a decision along these lines? For this, won't it be a 1 to n minus 1 and sum minus 2? For this, won't it be a 2 to n minus 1 and sum minus 3? Right? Do you see the difference? As well as understand each of them. Right? Everyone understands this? Who does not understand this? You will be able to understand when I say, but it's important that you are able to do it on by yourself, like formulate this.
Could you please repeat how are they different?
Here I am starting from 1. So if 2 is the minimum, then my subproblem is this with sum minus 2. Here, when I am allowed to take it as many number of times as I want, my subproblem is still this entire array and sum minus 2. For this 3, my subproblem in the second case, when I am allowed to take it as many times as possible, my subproblem includes 3. It's 1 to n minus 1 with sum minus 3. And if right here, and if I don't include, if here in this case, if I include 3, my subproblem is 4, 5, 6 with sum minus 3.
Got it. Okay.
Right?
I got it.
Yeah. So your homework will be to code both these solutions. The 2 decisions that I told you, you have to code for both these decisions. The combination sum problem that I gave you, code it for these 2 decisions that I told you, using whatever we have learned so far. You have tomorrow we will talk about how to not take explicit return types. So I will talk about, we want the function to return a value, but not an explicit return type. So we will make our code simpler through this, and we will make our code simpler through a principle which is called tailing. We will, or passing down the contribution, which is what we will be doing. And we will see these 2 questions, how they are modified to include these 2, as well as we will look at running times of questions, and we will look at more decisions and more subproblems. So my entire more decisions and more subproblems. So my entire goal behind teaching you recursion in this manner is that you should be able to formulate a problem recursively at level 1 itself, which is basically, you should not, when you are formulating this recurrence in your head, you should not be unwinding the tree, or you should not be drawing this tree in your head. Just with the decision, you should be able to write a recurrence without even, that's like a dumb way of writing it. You should not get involved into the complexities of this. You should, do you understand what I'm trying to say when I say this? So whenever you write questions, solve questions, try to come up with recurrences at the first level itself without even like doing it for smaller problems. Right? Did anyone understand what I said through this?
So for the second decision where you group it into n batches, there each batch you'll have to take, you'll have to consider 2 branches, right? Like for each, where you include the first one and you don't include the first.
No. There are n branches.
So
You
no,
have,
like in each branch, the
no
union condition.
No, just the union of these n. Because why will you take include exclude again? Like why are you getting confused? Is whatever I said complete in itself, right? This will give you all subset.
Yeah.
Yeah. So
Yeah.
you can let's see a recursion tree for that decision. Let's see. Things will become clear. Let's take a simpler case, 2, 3, 4, and let's take a sum of 6. I will have 3 branches here. One where 2 is the minimum, 3 is the minimum, and 4 is the minimum. If I have 2 as the minimum, the sub problem that I am left with is 2, 3, 4 again, and sum as 4. If I have 3 as the minimum, I am left with 3, 4, and sum as 3. If I have 4 as the minimum, I am left with 4 and sum 4, sum 2. Now from here again I will have just one branch, which is basically, so the number of branches that come is equal to the number of the size of the sub problem, the sub array that I'm left with. So here I just have one branch and I enumerate all subsets with 4 as the minimum. So if I consider 4, then I will be left with this 4 itself with -2. And then I know it's not possible. So I will return empty and I will return. So this branch is completely not giving you anything. Now let's come to this. So if you have, now again you will say that you have 3 branches here. You can have 2 as the minimum, 3 as the minimum, or 4 as the minimum. If you have 2 as the minimum, your sub problem becomes 2, 3, 4, and your with sum 2. If you have 3 as the minimum, your sub problem becomes 3, 4 with sum 1. And here you have 4 with sum 0. So this is a positive base case. You will return 4. And so here you will get 4 and you will return 2 here. So here you will get 4, 2, 4. That's 1. Let's think about other cases. Let's come down this. You have 3 branches here again. You can have 1 as the minimum, 3 as the minimum, and 4 as the minimum. This is 2, right? 2 as the minimum, 3 as the minimum, 4 as minimum. If you have 2 as the minimum, your sub problem becomes 2, 3, 4 with sum 0. This is again a positive base case. So you will return. So this is 2, 2, 2. So here you will get another set 2, 2, 2. Come down here, you will be left with 2, 3, 4 and -1. So a -1. So you not possible. So not possible here. Then again here 4, you will be left with 2, 3, 4 -2. Not possible. This entire branch is done. From here you are just returning a 2. So this is done. This branch is done. This branch is done. Let's talk about this branch. You have 3. So now you have 2 branches here. You can include 3 as the minimum or 4 as the minimum. If you have 3 as the minimum, your sub problem is 3, 4 and 0 sum. So this is a positive base case. You will return 3, 3. Correct? So you will have a, did I make some mistake? The sum was 4, right? So with 3, this will become 1. Sum is 1. So with 3, it becomes -2. So this is a -1. With 4 also, it becomes -3. So this is also a -1. So there you don't get anything more here. and you can similarly come down here, right? So from here you got 2. So how many subsets with 2 as the minimum? 2 subsets, 2, 2, 2 and 2, 4. Now from here, if you enumerate, you will get one subset with 3 as the minimum, which is 3, 3. From here, if you enumerate, you will not get anything, which we already showed. So this is the answer then. Here you will have 2 branches again. If you really want to do it, you can include 3. In this case, you will be left with 3, 4 and some 0. So you get 3, 3 here. Here you will be left with 3, 4, 4 and some -1. This is negative. Right? Is it clear? Do you see how it is unfolding?
Yeah.
Clear to everyone? And does everyone understand what my intention is with respect to teaching you recursion? It is that you should be able to define a recursive formulation from level 0 itself. See, when I wrote the recursive formulation, I did not have that tree in my mind. I did not unfolded it to see whether it is working or not. I just had a recursive formulation at level 1 itself, which is basically the root of the tree. From there only. So if I make sure things are consistent according to my decision and my formulation, then everything else will take care. And if I write the base cases correctly, then everything else will take care of itself. You don't really have to get into the complexities of thinking about how the tree will look like, how it will branch and sub-branch. That's the main takeaway from all these sets of 4 lectures that we will be having. You should be able to do this. People who are able to do this are able to solve tougher recursive questions. Do you understand the intent? Apart from Sasank, everyone else also understands this, what I'm trying to say? Yeah, so whenever you practice questions, try with this. So I just gave you a template or a framework for that. The decision making is actually the most important part of that. If you are able to make a decision and formulate your sub problems correctly, everything else, and write the base cases correctly, everything else will take care of itself. You don't really have to do this thing that people do and get into unwanted consequences. Okay. So your homework for tomorrow is these 2 questions. Try to code it using these 2 decisions. Tomorrow we will optimize this code. We will not have an explicit return type. We will define an implicit return type, and then we will look at more concepts, and we will look at higher sub problems. So these sub problems that I gave you, what were these sub problems? These are 2D sub problems, just to give you an idea. Correct? So what is the two-dimensional nature of this sub problem? You have a suffix array. This is 1 dimension, and you have a sum. This is another dimension. Correct? So this is a 2D sub problem that we are talking about. There will be 1D sub problems also, where you will just have a prefix or a suffix array as the sub problem. There will be 2D sub problems where you will just have a 2D array as the sub problem. There will be higher dimensional sub problems. So the reason I am introducing this sub problem right away is because in dynamic programming, you will be doing nothing but storing these sub problems, so that you can reference it at a future point in time. Everyone understands that these questions that we did today are 2D sub problems? And do you appreciate that suffix array is 1 dimension and the sum is another dimension of the problem? Okay. I will give you a couple of more questions to think about. I don't expect you to do them, but the decisions are similar for these questions also. Try these questions also. Okay, try these questions along with the question that I gave you. If you are really interested, try this question also. this is a little more difficult. But we will discuss these questions tomorrow anyways. Like we will take it up in the class. So it's okay if you don't do it also. But try the combination sum question with the two decisions that I told you. Like just have in your head how the recursive implementation will look like. All right. So there's too much light, right? All good so far? Any issues with recursion and like till now? Can I have one final set of acknowledgements before we disperse? It's already 11:35. All right. All right, guys, then I will see you all tomorrow. We will level up questions, discuss more tougher questions. I'm around for a couple of minutes if you want to talk about anything. Otherwise, I will end the meeting if you don't have anything else to talk about. People who don't have anything can leave also.
Excuse me, sir.
Yeah, Mansi.
So could you explain how do you handle the negative base case?
Yeah. So the negative base cases that I told you, the way we were handling, see, negative base cases are basically nothing but no solution, right? So think about what a solution is here. What is a solution? Solution is a 2D array, right? A 2D array wherein each row is an array, is a subset. So this is the solution. So what will no solution translate to? No solution will translate to an empty 2D array. What will sum equals 0 translate to? And even if you have, let's say, some numbers in the array, what will this translate to? This will translate to just one subset, which is an empty subset in this 2D array. So we just made this distinction between this and this.
Okay, sir, got it. Thank you.
Any more questions? Yes, we will discuss merge sort. If you see, there is one lecture for recursive sorting algorithms, wherein we will talk about merge sort, quick sort, and their applications also.
So can I ask a question from shorting?
You can. Okay.
So मतलब जैसे मुझे अगर कोई एरे शॉर्टिंग करनी है कि एक मैं चाहता हूँ कि मतलब माउंटेन के उसमें कि एक मैक्सिमम नंबर है उसमें कोई 7 मतलब मान लिया मैंने कि वो मेरी एज ए शॉर्ट एक माउंटेन के टाइप में जैसे फर्स्ट इंक्रीजिंग एंड देन डिक्रीजिंग तो सर उसका कंपैरेटिव फंक्शन क्या बनेगा?
नहीं, अब क्वेश्चन बताओ मेरे को फिर, मतलब एग्जैक्टली क्या है क्वेश्चन?
नहीं मतलब सर जैसे कोई एरे 2 3 समथिंग एरे और उसमें कोई मैक्सिमम नंबर है और कुछ नंबर्स रिपीट भी हो रहे हैं तो मतलब मुझे इस टाइप में एरे अपनी शॉर्ट करनी है कि पहले वो इंक्रीज हो देन डिक्रीज हो.
पहले वो इंक्रीज हो फिर वो डिक्रीज हो. यार वो तो इजी है ना.
फंक्शन बना सकते हैं तो कैसे?
वो तो इजी है ना, मतलब आप n/2 के अराउंड स्प्लिट कर दो ना, मतलब शॉर्ट कर दो पूरे एरे को और सेकंड हाफ को रिवर्स कर दो.
सेकंड हाफ को रिवर्स
नहीं, मतलब आपको माउंटेन एरे बनाना है. क्वेश्चन मेरे को भेज देना वैसे एग्जैक्टली. आई एम जस्ट थिंकिंग. You have to create. You want to create a mountain array, right?
Yes.
From an array.
Yes.
So, मतलब give me the question. Is it like this type of mountain,
yes,
or is
sir.
it?
Yes, sir. This one.
ये वाला
Yes, sir.
ये विगल शॉट है ना?
हाँ.
अरे ये नहीं कर पाओगे, ये अभी मैं कराऊंगा क्लास में. This is a good question. We will do it in class when we talk about merge sort. This is like, इसमें बहुत सारी चीज़ें लगेंगी. इसमें virtual indexing भी लगेगा, इसमें quick sort भी लगेगा. If you want to do it in order n and order 1, so I will discuss this in class. It's not an easy question. ठीक है? But if you really want to think about it, the one way you can think about it is that these numbers you can take from the second half of the array. These numbers. ये जो नंबर्स है ना, ये नंबर्स आप पूरे एरे को सॉर्ट कर दो. ये फर्स्ट हाफ है, सॉर्टेड एरे है, ठीक है? तो ये फर्स्ट हाफ से ये वाले बना दो आप सारे, और इस वाले हाफ से ये वाले बना दो. समझ रहे हो? क्योंकि ये हाफ पूरा का पूरा इस हाफ से बड़ा है, तो इस वाले हाफ से ये बना सकते हो आप. बट उसमें भी एक्सेप्ट नहीं होगा, उसमें भी एक आधा कॉर्नर केस रह जाएगा. मतलब उसको भी एक स्पेसिफिक ऑर्डर में बनाना पड़ेगा, विच इज की
काफी सारे केसेस आएंगे.
नहीं आएंगे. मतलब ये मैं बताऊंगा, आई विल टेक इट अप इन क्लास. इट्स अ टफ क्वेश्चन, मतलब इट्स नॉट एन इजी क्वेश्चन. ठीक है? इसको बनाने के लिए मैं आपको खाली हिंट दे देता हूँ, आप प्रूव करना कि व्हाई दिस वर्क्स. इसको आपको बनाने के लिए बेसिकली इस वाले हाफ को आपको ये रखना है, बेस ही रखना है माउंटेन का, बट डिक्रीजिंग ऑर्डर में रखना है. तो ये वाला जो एलिमेंट होगा वो ये होगा, ये वाला जो एलिमेंट होगा वो ये होगा, ऐसे करके. और ये वाला हाफ भी आप इधर रखोगे बट डिक्रीजिंग ऑर्डर में. तो ये वाला एलिमेंट यहाँ रहेगा और ये वाला एलिमेंट यहाँ रहेगा, तब बन जाएगा. आप ये खाली कोड करके देखना, ये एक्सेप्ट हो जाएगा. ठीक है? सोल्यूशन समझ आया आपको?
कैसा?
सोल्यूशन समझ आया ना?
हाँ, थोड़ा सा.
हाँ, मतलब आप सोचना इसको, वैसे हो जाएगा. बेसिकली सॉर्ट द एंटायर एरे, डिवाइड इट इनटू टू हाफ्स, n by 2 n by 2, मतलब n by 2, एंड दीज टेक दीज एलिमेंट्स. ये वाला एलिमेंट को बेस बना दो, फिर इस वाले एलिमेंट को इसका पीक बना दो, फिर इस वाले एलिमेंट को इसका बेस बना दो, फिर इस वाले एलिमेंट को इसका पीक बना दो, ऐसे करके एंड सो ऑन. फिर इस वाले एलिमेंट को यहाँ से ले आओ, इस वाले एलिमेंट को यहाँ से ले आओ. ऐसे करोगे तो हो जाएगा. ये सॉर्टेड एरे है. बट अगर आपको, तो ये n log n में होगा. अगर ऑर्डर n और ऑर्डर n टाइम और ऑर्डर 1 स्पेस में करना है तो वो मैं क्लास में कराऊंगा, वो थोड़ा हार्ड है. ठीक है?
ठीक है, थैंक यू सर.
Anything else? All right, guys. Good night then. Take care. Stay indoors, stay safe. I will see you again tomorrow. I will end the meeting now. Thank you.